So until now, we had many examples where we would break down a set into a few different subsets or a few different categories that were non-overlapping, and that allowed us to use the addition principle. But what about if we cannot break them down like that, but instead there is some overlap? Okay, so we use something called inclusion-exclusion. So here's a little example to maybe illustrate it. So we have here two sets A and B, and there is some overlap among them, right? So each dot is an element. So how many elements does A have? You might say 3, but that's not correct. A has 5 elements. How many elements does B have? B has 6 elements. So if I just count the elements of A plus the elements of B, that would give me 11. However, there aren't 11 dots here. So what's the idea? So if I want to know the cardinality of A union B, I'm sorry. Oh, this is a mistake. Okay, this should be a 9. Okay, so the point is, if I want to know the total number of dots, right, the total number of things that I have in this thing, A union B, I can count the number of things that I have in A, which is 5, and then I can count the number of things that I have in B, which is 6. But the problem is I'm over counting because I'm counting this middle part twice. So what I have to do is I have to manually remove it, right? So I have to subtract this middle part, meaning subtract the cardinality of A intersected with B, or -2. And that gives me an answer of 9, which is the correct number of dots. So this is the idea of the inclusion-exclusion formula. So here it is. Here's the inclusion-exclusion formula for 2 sets. There are different forms of the formula depending on the number of sets we're dealing with. We're only going to be worried about 2 sets. Okay, so here it is. For any 2 sets A and B, the cardinality of A plus the cardinality of B. Whoops, something's missing here. Okay, so here it is corrected. For any 2 sets A and B, the cardinality of A union B is equal to the cardinality of A plus the cardinality of B minus the cardinality of the intersection of A and B. Here's an example where we use this formula. How many 3-card hands can be formed from a standard deck such that all 3 cards are red or all 3 cards are face cards? So a red card is either a heart or a diamond. So you can have a mixture of hearts and diamonds, right? So they're all red, or they're all face cards, meaning Jack, Queen, or King. Now the problem here is if you try to make 2 categories, one being red cards and the other being one being 3-card hands that are red and 3-card hands that are all faces, you'll get some overlap. Okay, so we'll see that. So we have to use the inclusion-exclusion formula. So let A be the set of all 3-card hands where all cards are red, right? So some might be diamonds, some might be hearts, but they're all red in set A. It's a set of 3-card hands. So it's a bunch of different groups. It's a bunch of different groups of cards. It's a set. It's a set containing hands of cards, right? So it's a set, and within the set there are little sets, each of which is a group of cards. So what is the cardinality of A? Well, there are 26 red cards to start with, and we need to choose 3 of them. So that's 26, choose 3. That's the cardinality of A. Let B be the set of all 3-card hands where all are face cards. Now, how many face cards are there in a deck? Well, there are a total of 12 face cards, and we need to choose 3 of them. So the cardinality of B is 12, choose 3. Now note that there is overlap between A and B. As we said, for example, here is a hand of cards. Notice it's in curly braces because it's a hand of cards, meaning the order doesn't matter. Here we have a king of hearts and a king of diamonds and another king of hearts. Now it's not painted red, but that's just because of the picture that I took. But these really are red cards. I mean, this is diamonds. This is a heart. This is a diamond. This is a heart. These are all red cards. So these are all red cards, and these are all face cards. So this is a group of 3 cards, all of which are red and all of which are face cards. So there is overlap between A and B. This thing here, this little set here would be an element of A, and it would also be an element of B. It is an element of A, and it is not just a would be. It is an element of A, and it is an element of B. So I can't just do the cardinality of A plus the cardinality of B, right? That was when we learned about the addition principle. We can just add up the 2 cardinalities, and easy enough. However, here there's overlap, so we cannot do that. So we have to use the inclusion-exclusion formula. So for that, we have to first figure out what is A intersected with B. So A intersected with B means things that fall into both categories, right? So it's the set of all 3 card hands of red face cards. And these are 3 card hands of cards that are all red and are all faces. What is the cardinality of A intersected with B? Well, there are 6 such cards. If we go back to the picture of the deck of cards, we see that if we look for red face cards, we look for cards that are red and faces, there are exactly 6 of them. And we need to choose 3 of them. So the cardinality of A intersected with B is 6 choose 3. Now, by the inclusion-exclusion formula, the answer to our question is the cardinality of A union B, right? So these are all cards that are either, all 3 card hands that are either all red or all faces. So that's the cardinality of A union B. That is the cardinality of A plus the cardinality of B minus cardinality of A intersected with B, which is 26 choose 3 plus 12 choose 3 minus 6 choose 3, which comes out to be 2,800. How about if we have 3 overlapping sets like this? So I'm just going to give you the formula for this. We're not going to go into it at all. We're not going to do any examples involving this, but if you take a probability and statistics class, you'll encounter this, and you'll even learn a more general formula that will work for any number of sets. Okay, but here I'll just give you the formula. The inclusion-exclusion formula for 3 sets goes like this. So for any 3 sets A, B, and C, the cardinality of A union B union C is, so you take each of the sets by itself and add them, you add their cardinalities up. So you do cardinality of A plus cardinality of B plus cardinality of C. Then you take all possible pairs of sets. So you do A intersected with B, A intersected with C, and B intersected with C, and you subtract those cardinalities. So you do minus this, and then minus this. Then you take all the sets together you take 3 sets at a time, their intersection, and you add that back in. The idea is that you do A and then B and then C, but you have to remove this overlap between A and C. You have to remove, between A and B, you have to remove the overlap between A and C, and then you have to remove the overlap between B and C. However, you remove this middle part too many times, so you have to add it back in. Okay, so that's the idea here, but we're not going to get in further into this.